It's time for another amazing chemistry video with Mr. Stapleton. Proudly sponsored by Farming You a Nice Coffee.
Hi guys, welcome to this video which is going to be about the collision theory, just answering some of the questions around what collision theory is and how we can answer some extended response questions which quite often come. So first of all, in order to be able to explain the collision theory, you need to make sure you have an idea in your head of what the collision theory actually is. Okay? So in order for particles to react, they have to collide with the minimum energy, which is the activation energy, and the correct orientation. Okay? So what we're talking about when we often talk about with collision theory is we talk about the frequency of collisions. Okay? So we're going to come back in all of these things, talk about the frequency of successful collisions. And in particular, one word or one phrase that I want you to get used to putting in when you're talking about these, and you're talking about frequency of successful collisions, is per unit time. Okay? Per unit time is really key because that gives something that's measurable, that's quantifiable if you're talking about an increase in the rate of a reaction. Okay. So what I'm going to talk about firstly is just some of the ways that we can show activation energy on some graphs. So I'm going to introduce two different types of graphs to you. Okay. So the first one I'm going to introduce is one that you've probably seen a little bit before. Okay. It's called an energy profile graph. Okay. So energy profile graphs. Okay. They have energy along here. Okay. And along the bottom they have the reaction pathway. Okay, so what they do, there's two ways, two reactions you can show with an energy profile graph. One's an endothermic reaction, one's an exothermic reaction. So I'm just going to show an exothermic reaction here. So in an exothermic reaction, energy is given out in the reaction, so the enthalpy is a negative value. So in an exothermic reaction, the energy of our reactant, which is up here, is higher than the energy of our products down the bottom here. So we've got energy given out. Okay? Now the reaction actually progresses like this. Okay? And so we have to input a little bit of energy to begin with. So the energy that we input is this bit here, is the distance between the top and where our reactants are. That is our activation energy, EA. Okay? So we have to supply that energy in order for this reaction to occur. Once we've supplied that energy, all right, then because it's an exothermic reaction, this value here is our enthalpy, the difference between our reactants and products. In this case, we're supplying energy, or giving out energy, I should say, from the reaction, and that gives the energy for it to occur. Okay, so that's one way we can show the activation energy using an energy profile graph. The other one is using what's called, and I'll swap colors for this one. All right, it's called an energy distribution graph. Okay, so they're a little bit different, and we're going to come back to these in the next video when we look at some specific examples. Okay, so in an energy distribution graph, again, what we've got here, all right, is on this side now we've got energy now down the bottom. Okay, so the difference between energy was up here, this time it's down the bottom on the x-axis, and here we've got number of particles. So what we have in an energy distribution graph is a bell curve distribution of our energy, of our particles. So it looks a little bit like this, okay? And our activation energy, I'll use the green again, is the minimum energy required for the reaction to occur. So normally activation energy for a normal reaction is around about here. Here's our activation energy, which means that only these particles here, those to the right of the activation energy, will have the energy required to react. Okay, so an energy profile graph and an energy distribution graph are really important for you to be able to understand. You're going to use these in conjunction with this, right? With the fact that in order for particles to react, they must collide with the correct orientation and the minimum energy. Okay, and when you can understand that and be able to draw these, you'll be able to explain or answer questions in terms of the frequency of successful collisions per unit time, and ultimately what impact that will have upon the rate of a reaction. Okay, so that's all I'm doing for this first part of this video. It's just giving a brief introduction around collision theory and a couple of the graphs you can use. Want to make sure that you understand this in depth, okay, so you might want to watch it a couple of times before you start going on to the next video where I'm going to explain some answers to some questions and how we apply the collision theory to everyday situations using these graphs to talk about frequency of successful collisions. All right, thanks guys.